today. But the first thing that we will treat you with is really a treat. It is Diane Fresquez, who is a science journalist from the US and Brussels, who has written a book called The Taste of Molecules about the pH scale and food sciences. And she's here on stage together with Professor Dr. Jürgen Wendland from the Carlsberg Laboratory. And they will talk about beer and the pH scale.
Okay. So I've named this, from beer comes the pH scale, but it's rather odd. So just tell us, what does beer have to do with the pH scale? It's an odd combination.
No, it's not, because if you want to do beer, you actually want to control several processes, and in doing that, you want to know whether they're in specification and they're running smoothly and they're running okay. And if you can measure the pH, you actually know that this will be a good beer in the end, and you have a good malting, you have a good mashing, and the final pH of the beer is also very important because that gives you flavor and taste. And if you have a really good insight into that, you can make consistently good quality beer. And that's why Carlsberg became interested in this.
Right. So the big news is, because it's a little piece of science history that's been lost in time, is that the pH scale was developed here at the Carlsberg Laboratory in 1909. So
yes, right.
So during my research for my book, I came here to Copenhagen, to the University of Copenhagen, and it's a long story about sitting in a castle with a Danish scientist, but I discovered this fact that I hadn't known before. And in my book talks, I use it a lot, and I find that the general public, scientists, have never heard of this, but they're absolutely fascinated about it when they do hear about it. So, so can you just quickly give us a quick run through of all of the science, because there's more science that came out of the Carlsberg Laboratory for more than 100 years.
Right. The Carlsberg Laboratory has been founded over 140 years ago, so we did some breakthrough achievements in science, and we have two departments initially. One was physiology and the other one was chemistry. And the chemists, they invented, for example, Kjeldahl, a method for determining the nitrogen content in barley. That's also important to make good beer. And then Sørensen came with invention of the pH scale. And we had other chemists that work on the protein structure and also on chemical ways of making polymers with the click chemistry. That was most recently. And on the other side, we had the yeast people, and I'm also a yeast person. And that was one thing we did, was purifying lager yeast strains. That was done by Emil Christian Hansen in 1883, and that made beer production in industry with using pure culture yeast strains. And then we had Øyvind Winge, who actually figured out the sexual cycle of Saccharomyces cerevisiae, which is good for yeast breeding, to make new traits, to develop new traits and new strains. And recently...
recently, your big news.
Recently, yeah. I just sequenced the original yeast Saccharomyces carlsbergensis, so we did some genomics on this strain, and we could figure out what's the relationship of Saccharomyces carlsbergensis with other yeast strains that are used in production all over the world.
But getting back to that just briefly about Carlsberg, is that yeast was given away by Jacobsen, wasn't it? He was a great fan of having this science that was open to everyone and not patenting it and so forth.
Right. Jacobsen, he founded the Carlsberg Laboratory, and his idea was to, not keep stuff secret, but publish it. And he gave Saccharomyces carlsbergensis freely to everybody who wanted to have it, to actually, promote brewing science and making good quality beer.
Okay. So, remind us of what the pH scale is, because some of us aren't scientists, some of us haven't taken science in a long time, but I think all of us are familiar with it from high school, even if we didn't enjoy the process. So just remind us of that. What is the pH scale?
I'm a yeast person, so I'm a physiologist, not a chemist, so I will not bother you with too much chemistry. But basically, the pH scale gives you a measure of the hydroxonium ion concentration in a liquid. So pH runs from 0 to 14. There's no unit with it, and it gives you a concentration. So pH 7, for example, would be the concentration of 10 to the minus 7 moles of protons in your liquid. And since it's the negative logarithm of this concentration, you can just have pH 7 for a neutral, what we call neutral in water.
Okay, so it's a scale. It's very colorful. It's very rainbow colored. We've all seen it, 0 to 14. And if I had a slide now, I'd show you, but I don't have a slide. So in fact, we're going to make our own pH scale here. So I've actually brought you a present. I've brought you quite a few presents.
Okay.
So basically, hydrogen, as I understand it, and I'm not a chemist either, is the most common element in the universe, not just in the world. And so if something has hydrogen in it, we can take the pH. So we can take the pH of almost anything, and most things in the world have. I've brought you a box of hush puppy shoes, of things that represent. So we'll just come over here to the table, and things that represent substances in the world that we can take the pH of. So you can reach it. Let's make the pH scale first. So as they say on all the great cooking shows, here's one I made earlier. I think we're going to have to start from there. So I took a little liberty with the colors. I don't think gray should be in there, but this is all the paper I had. So here it goes. So we've got 0 to 14. And just reach in there. Some will be kind of obvious to you, some...
That would be nice.
Okay, so we've got water at number 7.
Right. That should be here.
Right. And the next thing?
What can I recognize? I know this one.
Yes. So we've got Coke. And can anyone guess what Coca-Cola, the pH of Coca-Cola is? 5? It's
4.
4. Keep going.
Keep going.
Keep going. It's a 2.
Okay.
Vinegar is here, by the way. Battery acid is right next door. So, what do we got here?
This is bicarbonate.
Okay, so baking
sodium
soda.
bicarbonate soda. So if you dissolve this in water...
Again, guessing what the pH of baking soda is, it's 8. So we've got it here. And you'll notice, so I don't have everything here, but most of what we eat is 7, so that's neutral, that's water. Most of what we eat and drink is on this side of the pH scale. Baking soda is alkaline. So I just want to explain again so we're very clear. All of this is acid up to here. This is neutral. From 8 to 14, we've got alkaline. So what we're eating is on this side of 7. So what have we got here?
There are puppies.
No, don't open it yet. Don't open it yet. Okay, so we have a little figurine here. This is going to represent humans. So we've got humans here, and we're going to start with, I got some information from the Massachusetts General Hospital. So human blood normally tests within a very narrow range. That's 7.35 to 7.45. And higher or lower blood pH values can help diagnose metabolic and respiratory problems. So every time you're going to the hospital or the doctor and you're having your blood tested, maybe they're taking the pH and they're getting some information from that. So you can, but before you put her down at a very precise 7.35 to 7.45, can you open her up?
I can.
Okay, so there's another little person in there.
Smaller one.
So we're just going to continue down the road of bodily fluids here. So we've got this person, and we're going to talk about the pH of urine, which is also something that you get tested when you're in the hospital or at a doctor. Urine runs, it's a huge range of pH from around 4.6, so around here, to 8. But it's commonly analyzed for pH to help detect such problems as diabetes, which is high acidity, so something around here if it's out of the range, and urinary tract infections, high alkalinity. So we're just going to let her sit somewhere in the middle. So you've got a few more?
Well, how about this?
Okay. Can we take the pH of this? Well, this is the pot scrubber. This reminds me of cleaning up and having all of the stuff in the sink go down the sink and block your drain and you need to use drain cleaners. So I'm bringing all of these things in my suitcase from Brussels. I couldn't bring drain cleaner and battery acid and all of these things. So 14, that's a very strong caustic thing. What I think is neat about this scale is we've got 7 here, which is neutral. And it doesn't go from 0 to 14 from higher to lower. It starts out here neutral, and going towards either end, it becomes very caustic.
Okay.
So next. Do you know what this is?
Nope.
This should be familiar to you because this is a little sample of Carlsberg soil.
Okay.
And in fact, I've got 2 in here, so they're a pair. So soil is very complicated. As I said, you can take the pH of nearly anything, but it has to be in liquid form. You can take the pH of something like soil. It's very important to crops and so forth, but it needs to be put into a liquid, which I'm not going to get into explain. It would take a whole other couple of hours. So, but I did get some information from the Precision Soil Tech company in Australia. And when they were testing the pH of Australian soil, they had it ranged between, in the same area too, so it went from top to bottom, top soil to bottom for about a foot, and that ranged 3.5 to 7.5. I really should have had, we can't see the scale. So another one, so 3.5 to 7.5. Okay.
And then we have this.
Okay, we've got to this one now. So what I wanted to do at one point is I was looking at all of the other events here in Science in the City, and there were some quite intriguing ones. And there was one that was on Saturday and Sunday, and it was called Come and Get Your Sperm Analyzed. So I needed a little representation of sperm, and I think he's quite good because he's got the little tail. And I don't think he's going to do very well swimming with just the little tail, but I think he has a secret power somehow. So, very important for fertility. So I wrote to the organizers and they gave me some information, and indeed they do take the pH of sperm to determine things about fertility. So normal seminal fluid is slightly alkaline, pH 8, 8.5. Neutral, so 7, or slightly acidic, 6.5 or 7, can indicate problems with fertility. So we've got, what did I say, pH 8 to 8.5. Okay, is there anything else in there?
Last one.
Last one, battery. This represents battery acid. You might know the answer to this one. What is the pH of battery acid? 0. That's right. So, but since we're here with the pH of beer, it must be very important that we put some beer out. So another present I brought you is some beer from Belgium. And if we can just put those out. And of course we've got the Carlsberg as well. We're going to, so pH of beer. It is, you can just, we'll bring those out. So pH of beer is usually around 4.5. I had someone in Belgium from the Belgian beer tasting company help me choose these. So 4.5, where are we? About here. And later we're going to taste these, and I'm really hoping to break the pH barrier with some of these Belgian beers, and we'll see later. So, but the thing is, most of these came in my suitcase. There is and they were small props because I'd bring them in my suitcase, but I also got something for you. Can you just hand me that?
Okay.
So they're teeny tiny props on a big... And there, so that we remember that the pH scale...
Yeah, you need to think big, huh?
It was developed at the Carlsberg Laboratory. So, let's come back over here and talk about Søren Sørensen.
Good.
Okay, so we've got Søren Sørensen already up here on the slides. He looks a little bit like Freud to me, but that isn't Freud, that is Søren Sørensen. So he was born in 1868 in Haverberg in Denmark. He died in Copenhagen in 1939. This year, 2014, is the 75th anniversary of his death. He served as head of chemistry of the chemistry department of the Carlsberg Lab for a long time, from 1901 to 1938. So tell us about his early life.
So the early life, he was born as the first kid of 7 of a farmer's family. So he lived in a farm outside of Copenhagen, of course, and he had some problems with farm life. He actually didn't like the animals too much. He didn't want to go near them. So and he had some problems with the health. So he stuttered and he had eye twitches, and the family really didn't know what to do with him. Could he run the farm? Should he do something else? So he went to school, and at school, the teachers actually liked him, and that promoted him to secondary education, and so he had to go to the city. In the city, there were city kids, and they didn't like this bloke from the country, so because of his accent, and there was a bit of mobbing going on, and he actually had to convince the strongest guys of this crowd that he's the better man, and it looked like he'd done that, so then he was respected. And in the early life, actually, there was one thing that he used his pocket money to buy a logarithmic table. So,
and the logarithmic table we know is a slide rule.
Yeah, there is right. You have a slide rule, and there's just some values. When you take the logarithm of a given number, you get another number.
Right. Does it look like this?
Faintly. So nobody uses this, of course, anymore.
I know. This is actually an antique that I brought you. This is a slide rule that I bought in high school, not with my pocket money. I think we were asked to buy it for a class whose name eludes me now. And I've moved a lot in the world, and I still carry this around with me. I have no idea. I'm waiting to learn how to use it, I think.
I did that in school.
Yeah.
But it was not very, fast.
So why was he interested in this area of research? Why is the measurement of acidity important for brewing?
Okay, as I said in the beginning, you need to monitor the whole process, and you need to be sure that the pH is within range to give you the right concentration of sugar in your wort, and to make the fermentation go fine. And at the end, the yeast will produce a pH of roughly 4.5 with your beer.
And when he developed this scale, was he instantly famous for this, or was this something that we have developed and used gradually all over the world?
I don't know exactly, because I wasn't there, but from the reading of it, I think today he would be a rock star. So with that, he became basically instantly famous, and today we have measurements of fame for a scientist. You see how many citations they get for their papers and how well this is all done. And from that, he got very soon like more than 1,000 citations of his work, and he received honorary degrees and awards and all this. And basically this publication in 1909 was seminal. It was more than 150 pages of a scientific publication, which is not done today anymore. It was basically a book. It was, you can compare it to Charles Darwin's work on the origin of species. So it made such an impact on science.
And yet, as I said, I've even spoken to people here in Copenhagen at Science in the City, at ESOF, and Danes who don't know about this at all. So it's amazing that it's been lost in history, and yet it's something so common we almost take it for granted, and we're using it in education, medicine, agriculture, industry, food science, brewing, all over. And but did he? Sorry, go ahead.
In Denmark, he was really famous. I mean, he was at the end of his life, he became president of the Royal Academy of Science.
Okay.
And since he only lived, that was in 38, and he only lived till 39. And then came Niels Bohr as the next president of the Royal Academy. So he was really famous in town.
So when we write pH, we write it with a small p and a large H.
Yes.
And that's a really iconic symbol that we all know, even if we're not in science, as I said. Was it always written that way?
No, he himself has written it with a large P and so a P here and an H down here. And then he added a dot, and His publication was both done in Danish and in French. So for the Danish version, it was actually pH with a dot, and for the French version, it was a pH with a plus. But he had like a larger P and a smaller H, and then it just got reversed. And to my knowledge, this is actually not known who introduced the new way of writing.
And there is some debate about what pH actually stands for, and a lot of people say it stands for the power of hydrogen. And is that true, or we're not quite sure about that?
Well, in school I learned this is pondus hydrogenii, the power of the hydrogen. That's the general assumption. But actually from reading his paper, the idea is that P was just an ordinary variable because he used P and Q as a variable for a buffer solution, and he invented a whole range of buffer solutions to monitor stepwise pH. So Q was the variable for the known solution, and P was actually the query, what you actually wanted to find out. So he didn't give it any further meaning than just variables P and Q.
I think you said there was something interesting about the dot or the period that pH period or plus. Yeah. That's been lost, that little period.
Right. This was then just eliminated, either as a radical dot or a plus for the ion. This is not used anymore.
Okay, and so he did this tremendous work and has left us with such a great scientific tool. Was he nominated for the Nobel Prize, and did he ever win?
Yes, he was nominated. He was actually nominated for chemistry, and he was also nominated for physiology and medicine because of all the relevance of pH also in the medical arena. But no, he did not get it.
He did not get it.
There are some sayings that people of the Nobel Committee thought that it's not, a natural law he invented. It's not like Einstein's E equals mc square. So they diminished his achievement a bit, or they didn't see the full potential of it.
Right, that we see today.
Yeah.
And tell me, because I'm so interested in what he was like as a child. I mean, he grew up on this farm, and you say he had either no books or very few books. Yeah. He had some problems with stuttering and that sort of thing. And he was a shy boy, an awkward boy, and all of a sudden he's working in the Carlsberg lab, developing all of these things, and he's head of chemistry, and he's a mentor to other scientists. What was he like as a person himself, as a teacher and a personality?
So people reported that he was a very, very good teacher. He took a lot of effort with his people, and he was very meticulous. He was very accurate with his research, and that showed actually. His publication gave a lot of insight, and he produced a lot of buffers that could be used, and he really gave a handbook of how to use pH scale to the scientists, and this was so well worked out. It was just instantly obvious that this thing really works, and that's why it was used. And I mean, his stuttering he got rid of at the age of university. He did a similar thing like Abraham Lincoln. Abraham Lincoln was afraid of the public, and then he went to the woods and he talked to the trees to get really over it and to give good speeches. And Sørensen was kind of alike. He had long strolls in the wood, and he talked to the wood, and he got his stuttering over by making a very poignant voice, and this helped him a lot. And
I think this picture is really lovely, the old-fashioned picture showing him in the lab. I don't believe that's pH that he's working with here. I think that was protein or something.
That's a protein. That's egg albumin.
This is actually a painting that's hanging over there in the museum, or the Sørensen lab, which is still there. Is that correct?
We have paintings in.
Sorry, this is a photograph, but there's a painting as well.
Right, we have a painting of him in the Carlsberg Laboratory.
But I notice he's here in the laboratory, but he's wearing a suit and tie. So what was he like then as a scientist, walking around the lab with a suit and tie? Was this just for the photograph, or is this how he worked?
No, this is original. You could actually stage it and just make it up, but this was the way he worked. And there is a larger painting in our Carlsberg Laboratory that shows his whole group, and they all wear lab coats. And today, this is, of course, the way to do it. But he was such an accurate scientist, he thought he doesn't need one. It's a sign of being a very accurate and good scientist and chemist. He will not, ruin his Sunday jacket. He can just, work like this. And that's why that was his working dress.
That's wonderful. It's
Yeah.
a wonderful photograph. Do we have any questions about the pH scale or Sørensen or the Carlsberg Lab? Okay. Well, yes, you do.
Hi. Hi. Yeah, so just out of interest, after he had done this huge achievement that had all this impact across the world, what did he do next? He didn't lie back and relax, it doesn't sound like.
Well, Sørensen was very, very active. So before he'd done this pH, he actually worked on amino acid synthesis, and after his pH, he actually characterized the activity of proteins, because you can imagine proteins have a different spectrum of activity, and this coincides with the value of the pH. So he could actually see where is the maximum activity of a protein, and he was very interested in egg albumin, for example. So he found out ways to crystallize it, to precipitate it, and these are all very standard tools that today are still used by the chemists. So he actually determined the molecular weight of egg albumin, and that was pretty accurate for his methods. So he was really active, and he also was, a consultant for a lot of companies in around Copenhagen, and he did a lot of work in providing that. And there's also his work had impact on bakery, because the bakery industry has the same problem. They need to monitor the pH so that the bread rises nicely and actually tastes nicely as well.
Okay, and in medicine as well, he was acting as a consultant, isn't that right?
Oh, yes, as we just mentioned,
Yeah.
Your urine is a good indicator of how well you are, or how bad your last day was, or what you have eaten, and it's always good to check it. And if it's too high or too low, then there might be a problem. And if it's consistently too high or too low, then the doctor really can make some assumptions on what is wrong with you and assign a treatment,
Right.
or do further tests.
Can I
So-
just ask one more question?
Yes.
Sorry, that's me again, and I meant to ask this before.
No.
Was it for his work on his PhD that he did the work on the pH? That would be beautiful, no? If it was if his PhD thesis was developing the pH scale.
You have discovered what pH stands
There we
for.
go.
So, no, that wasn't it. So he got his PH in 1899, and he started at the Carlsberg Lab basically in 1901. And at the university, he always was already famous. He got some gold medal prizes for his analyses that he's done in earlier times on strontium salts and radicals. So he was pretty well known already.
That's pretty good for a farm boy who grew up afraid of the animals and with
Definitely.
no books in the house.
He made a lot of changes, definitely.
So, in order to celebrate this tremendous achievement, I began about a month ago with a sort of Twitter campaign called Selfies, spelled with PH. And I asked people in Twitterland all over the world to send me some photographs of them taking the pH of anything they wanted. And we got a really, really good response and a lot of followers. It was great fun. And Science in the City was very generous, and they gave me 5 tickets to ESOF to give away to 5 winners. So I'm going to show you the winners now, and one that wasn't a winner that I like anyway. It's rather bizarre. Let me see if I can make this work. So this is coffee, pH 5, taken by a PhD student, researching microbial and waste biofuels at the University of Bath. So you can see there, and he's taking the pH of coffee in a mug with a picture of a molecule of coffee. So really into it scientist. This is a lot of chemicals here, different chemicals, hydrochloric acid, vinegar, glass cleaner, sodium bicarbonate, ammonia, and this is from a student at the University of La Rioja. And this is, we have this person in our audience here. This is Mike Beckers, one of the, a journalist from Germany. And he took the pH of vinegar, which is around 2 to 3. The next one. This I really love because they took the pH of, this is from Italy, they took the pH of various chemicals and then matched the colors up to those coffee pods. And I thought that was extremely creative. It wasn't exactly what I asked for, but I thought it was lovely because it really goes to show it's such a bright and colorful and easy and inexpensive and easy to use tool for anybody in any industry. So this one didn't win, but I like it anyway. This is a photograph of a dead mouse taking the pH of vinegar, pH 3, and I really love his little top hat. And to bring us up to our beer tasting, which we haven't forgotten about, this is one I really, really like. This was actually our first selfie, which I was really impressed with, because this is a Guldendrak Belgian beer around pH 4, so quite sour. So I want to say, if beer is 4.5, most beer is 4.5, and this, what she's drinking, is 4, that means it's 5 times more acidic than normal beer. Is that correct?
Yeah.
So they move 10 each time. So she's a Serbian PhD student in neuroscience at the University of Ghent. Is there any more? So we'll put it back to Sørensen. So now we're going to taste some beer. And I'm going to have a volunteer help me take the pH, or take the pH. And I'd like you to taste it and go through it. So where are we now? That's good. And after we determine the pH of some of these, do you want to come up, Mike? So we've got some...
I got an opener.
Have you got an opener? Okay, opener. Okay, so which one would you like to start with? Where'd the Carlsberg go? 1, 2, 3.
That's this one.
Where's the brown? There it is. Oh, we've got one more.
Oh.
So this is called... So we're going to start with the Carlsberg. You can take one of these little cups. I suppose you've tasted Carlsberg before, so you don't need to taste. So, Mike, if you want to take... Hold it in, I think, just 2 seconds or a little bit longer. And tell us what the pH of that is.
I guess that's 4.5.
4.5.
Very good.
On the money. I'm going to have you look at these first, the Belgian ones. This is called Owa Sakura, a lambic from Belgium. And they say here that their tasting notes is delicate notes of cherry blossom. So Sakura means cherry leaves in Japanese. The leaves are steeped in salt for several months, producing a highly perfumed aroma. Do you want to hazard a guess as to what the pH is going to be of this one?
Okay.
Just by looking at it, that it's a lambic. So a lambic, I'm not an expert on beer. I don't think I'm an expert on anything, but I knew it was going to be a corkscrew one.
Okay.
So the lambic is meaning that it's developed with wild yeast. Is that right? The yeast from the environment in the brewery. So you've got enough. Can you smell it? Does it really smell like?
Yes, it smells.
Cherry blossoms.
Let me see.
So taste it, because we don't want to.
You do it.
Yeah. Give it a bit of a taste. And the pH of this. Don't drink it after you drink a lot of it and then take the pH. We don't want to drink it after we put the strip in. I don't think. I don't know what's in those strips.
It's a bit on the sour side, so...
It is. So you're thinking the pH is going to be lower than...
It's dropped 3.5.
3.5.
You're right.
Here you go.
3.5. Okay. Another Belgian beer, craft beer. It's called Enfant Terrible. Not terrible, but terrible. And that means it's a triple beer. I believe that triple in, if it's a beer from the Trappist breweries, that means it's a very strong ale. I don't think that's what this is. It also means triple fermented. So any guesses to that before you even open it and taste it? So this one they describe, it's a blonde beer, fine bitterness. So we're bitter on the bitter side with a subtle touch of citrus.
Sour.
Accompanied by a sober, spicy, malty taste. Yeah? So, enfant terrible, what do you think the pH is going to be?
I don't know, around 4.
4?
Yeah. 4, 4.5.
Okay,
There you
good,
go.
excellent. This one is called Embrasse. Now, this one is brewed with 8, what they call exquisite malts. And usually beers are brewed with, I believe, 1 or 2 malts. So 8 malts. It's going to be very malty. Nothing about triple yeast or anything. And it has some really lovely packaging as well.
You want to do it? Go ahead.
That came in the suitcase and hasn't settled down. That's all right. Carry on.
That happens.
Malty. What do you think? pH? Is it sour?
Not so much.
Yeah, 4.5, 4.
4.5. Okay.
Good.
I saved this one to last because when we were talking about this event, you mentioned a beer that might be quite interesting to taste. It's quite sour, and it was it's Berliner Weisse.
Thank you. Yeah.
So from your country, and now this is from Belgium. So it is a typical Berliner Weisse, but it's made also with added Belgian yeast. And they describe it as sour and wild inside. And it's from the Brussels Beer Project.
There you go. So if it's a real Berliner Weisse, then it's not only fermented with yeast, but also with some bacteria, and then it has to be acid. So the pH should
Acid
be
in a good way?
3.5
Yeah?
or a bit lower. That's the way it should be.
Okay.
No, it's 4.5.
You sure? Well, then that's the way it is. But Berliner Weisse from Berlin, that's since you have bacteria in there, they will reduce the pH just by their metabolism.
You know what it is? It's the extra yeast from Brussels, I think, that's maybe
Yeah.
brought it back up. But so that was great. Thank you very
Super.
much. And
Thank
if you'd
you.
all like to come up and do a bit of tasting as well, I think we've got some time. We've taken the pH, so let's not waste any more beer on the pH at all. So you can come up and taste. Do we have time? Yeah, we have a bit of time. So I want to thank Pierre Zuber from the Belgian Beer Tasting Shop for helping me pick out these beers. And Professor Wendland, of course.
It was a pleasure.
And I thank Carlsberg and Science in the City. And thank you for your questions. And thank you, Mike Beckers, as well. So let's drink beer. Carlsberg has also provided a giant keg of Carlsberg beer. It's 10 in the morning. And what I was told by Pierre Zuber, the expert in beer, is that when they do tastings, they usually do them in the morning because your taste buds are most sensitive. So for the sake of science, let's drink some beer, okay? Thank you very much. Thank you. Thanks.